And now let's go ahead and get started with number 1. Right here it says we are going to find the dimensions of a rectangle, and the area of it is 1000 meters squared, and we want the perimeter to be as small as possible. Alright, I would like to show you guys two super powerful words whenever we are solving word problems. The first word is know, and this means we are going to write down what we know, and sometimes we can draw pictures to illustrate the situation. Here we are talking about a rectangle, so let's go ahead and draw a rectangle. But we don't know the dimensions. So here's the deal. Whenever we don't know anything, let's just go ahead and label them with variables. We have two things that we don't know, length and width. You can use L and W, but I will do it the classic way, X and Y. X is usually horizontal, and then Y is usually vertical, so like that. Now, it says the area is 1000 meters squared, so we know area based on our picture is just X times Y, and that must be equal to 1000. Okay, so that's pretty much all the information that we know. And the second powerful word is want, and this means that what do we want to know? We want the perimeter to be as small as possible, so that means we want the minimum of the perimeter. So how can we write an equation for the perimeter? Take a look at this picture. The perimeter means that you go around the rectangle, so we have X, and then this is also X. So we have 2X, and we have to add the width, Y and Y, so 2Y. Well, how do we find the minimum or the maximum of a function? We take the derivative, set it equal to 0, look for the critical numbers, yeah? And then try to see if the critical numbers will give you the minimum or the maximum, yeah? So here we will take the derivative, but the perimeter has both X and Y. Not that good yet, but don't worry. Let's go back to the constraint equation, and that's the equation that we know. That's the condition on X and Y. X times Y must be equal to 1000. We can divide both sides by X and say Y equals 1000 over X, and then plugging this into here, then we will get an equation in terms of just X. So P is equal to 2X plus 2Y, and Y is that 1000 over X. Perfect. And notice this is now an equation in terms of just X. So I can come here and say P is a function of X, and this is the function notation. If you keep it as P, it's totally okay. Now we will just take the derivative, but before that, let's fix this a little bit. P of X is equal to 2X plus 2 times 1000, which is 2000, and the X on the bottom, let's write it as X to the negative 1. We are now ready to take the derivative, P prime of X. The derivative of 2X is just 2, and the derivative of 2000 times X to the negative 1. Put the negative 1 to the front, and minus 1. So we have minus 2000 X to the negative 2. That's the derivative. Now to find the critical numbers, we will set this to be 0. And you have a couple ways to solve this. You can try to solve this by factoring, or I will do it this way. I'll put this to the other side and then try to isolate the X. So we get 2 equals positive 2000, and the X to the negative 2 is the same as saying over X squared. So let's do that. Now multiply both sides by X squared. We get 2X squared equals 2000. Divide both sides by 2. We get X squared equals 1000. And for this, we can just take the square root on both sides. And you should keep in mind, whenever we take the square root, we should have the plus or minus. But in this case, we are talking about length. So the negative doesn't make sense. The only critical numbers that we care is square root of 1000, and square root of 1000 is the same as X is equal to 10 times square root of 10, because you can break this down as 100 times 10, and square root of 100 is the next number 10. Alright, now we will have to test out if this is indeed a minimum or maximum. Let's do the second derivative test, meaning take the second derivative, p double prime of x. Look at this and take the derivative. Alright, the derivative of 2 will give you 0, and the derivative of this, we put the negative 2 to the front, and then minus 1. We get positive 4,000 times x to the negative 3. And when we put 10 square root of 10 into the second derivative, we will get 4,000 over x to the third power, and the x value is 10 square root of 10. And this is clearly bigger than 0, and that's all we care. So we can say something like this. The first derivative at 10 square root of 10 is equal to 0, and the second derivative at 10 square root of 10 is positive. Remember, when the first derivative is equal to 0, the tangent line there is flat. And when the second derivative is greater than 0, that means the function is concave up. So as you can see, we have a minimum. So we can just say, based on this and that, so there is a minimum at x equals 10 square root of 10. And in fact, this is the only minimum, so it's just the absolute minimum as well. And now, once we have the x, don't forget to get the y. Y equals 1,000 over x. And x is 10 square root of 10, so let's go ahead and put that down. Reduce this, so this and that cross out. Oops, the x is 10. Alright, how do we simplify this? We can multiply the top and bottom by square root of 10. Square root of 10 times square root of 10 is just a 10, and I can reduce this with one of the zeros. So in fact, y is 10 square root of 10 as well. Notice x and y, they are both equal to 10 square root of 10. So in fact, this rectangle is actually a square. And that's a fact. Whenever you have a given area, and if you want the parameter to be as small as possible, you are pretty much getting a square. And I'll just write down the answer in this case like that. We want the dimension to be 10 square root of 10 meters by 10 square root of 10 meters. So this is how I will present the answer.